Hi students, welcome back. Now we are going to start our next module and that is on finite state machines. So in this video we are going to talk about that what is a state and what is a finite state machine. We are also going to talk about the working principle of finite state machines and the types of finite state machine. So let us get started. So first of all, we have to understand the term state. A digital system that is either a combinational or sequential is going to take input, it is going to process them and then generate the output. In this complete process, we are not doing one single step. We take a sequence of steps. Sometimes we are doing computation, sometimes we are making some decisions and all different sort of things. All such things are called states. So a system can have different state depending on the number of inputs and the algorithm that is involved in calculation of the output. A finite state machine is made using different state. So as we discussed that states will make the transition from one state to other. We had described that when we take input, we process them based on our algorithm. We go through different steps. These are called transitions. Okay? If the number of such states, that means how many sequences or how many steps we are going to take in computing the final output. If these states are fixed or finite in number, then we call the system as a finite state machine. For example, you are given a task that you have to count from 0 to 7. That means I need to count only 8 numbers. That is fixed, right? Finite state machine will describe this sequence or the steps that will be taken by the system in computing the output. Let us talk more about FSMs so that we get a better clarity. A system, as we have said, can have a lot of state. It should be finite number, but it can be very high number also. But at one given time, the system will be present only in one state. That means it will be computing only one thing or it will be making a certain decision. It cannot be present in multiple states. Every state will have the incoming and outgoing connections. The paths which are incoming to the state will decide that where should be the next path going. That means where will be the next state of the system. Let us see that how many components are there in one finite state machine. A finite state machine will definitely have states that we have already described, and these should be finite in number. We are going to have inputs, and again these should be finite, and inputs will always be given by the user. Based on the inputs and the state, the system is going to calculate the output. The number of outputs also will be finite and they will be generated after the sequence of computations. And in these calculations, we are going to transit from one state to another, and that is what we call as state transitions. Now, what we have in front of us is a typical finite state machine. Here you can see S0, S1, S2, S3 till S7. There are 8 states. Some arrows are going out of the state, some are coming in the state. There are some numbers written on these arrows. What are all these things? We are going to talk about these in detail. But as of now, we should understand that the circles are representing the states. The arrows are representing the state transitions. On every arrow, two numbers are written, one on the left side of the slash, one on the right side. The left side number is the input, the right side number is the output. Now, finite state machines are divided into two broad categories. The first one is called Moore's machine and the second one is called Mealy machine. Moore's machine is a state machine which can work on its own. That means it does not need any external input all the time. It can keep on continuing the process just based on the present state. For example, if we say that the system need to just count up, we don't need any input. We have some count number and we can keep on counting 1 plus 1 plus 1 and so on. The second type of machine that we have is Mealy machine, where we need the input at almost every step from the user. So with the combined information of the present state and the input, we decide the next state and the output. For example, a vending machine. We are going to have a product as the output, maybe a soft drink or a chocolate bar. The user will insert the money and tell the choice of product. Based on the input from the user, the machine will generate the output. So students, now we have a good idea about finite state machines. Let us talk about the more technical things. We are going to talk about that how to represent a finite state machine using state diagrams and tables in our next video. Keep learning. Thank you.